Hello? Hello?
Hello.
Hi Diksha Didi, good afternoon.
Hi. Sorry, my mic was mute.
It's alright.
That's good.
Alright. So today we are gonna continue with where we left, that is the pointers chapter, and then today we are gonna learn about functions.
Okay.
Alright. So I'm just sharing my screen. Alright. So here, can you see the screen now?
Yeah, it's easy.
Alright. So C++ pointers. So first we are gonna see what are pointers, and then we are gonna see how to create pointers. So you learned from the previous chapter, that is the references chapter, that we can get the memory address of a variable by using the AND operator. So we saw that we can either create a reference variable using the AND operator, or we can get the memory address of a variable using the AND operator. Right? And here's the previous example. So a pointer, however, is a variable that stores the memory address as its value. So over here in our main.cpp, where we had this, right? We were just directly printing the memory address of our variable. But if we wanted to store the memory address, how would we do that? Right? So using pointers, we can store the memory address as its value. A variable's value can be the memory address, right? So a pointer variable points to a data type like integer or string of the same type. So this statement will be explained in a second with the example, and is created with the star operator. So like you create references using the AND operator, the star operator allows you to create a pointer variable. The address of the variable you are working with is assigned to the pointer. So let's just start with a fresh example. We have string x whose value is 4. Then what we'll say string, and then we'll have to give a star to tell that this is a pointer variable. And because we will point to a variable whose data type is string, that's why we'll have to say string star. If it was int over here, and like int x is 10, and we wanted to point to this x variable, then we would have to say int star, right? And then we can name our variable normally like pointer, and we can say and x. So and x will give us the memory address of this variable value 10, and then that memory address will be stored in the pointer variable. Is this clear?
Yeah, it's here.
All right. So if we let's just make it clear. Let's just show the value of x first. So we should get 10. Then let's show and x. We'll get this, and let's just show and x, and let's just give and l over here. Let's just show and x and pointer variable value together to see if they are the same. Alright, so these both values are the same. So this tells us that pointer has saved the memory location of our x variable. Is it clear?
Okay.
Alright.
Yeah.
So the example explained, we can create a pointer variable with the we are creating a pointer variable with the name pointer that points to a string variable by using the asterisk sign. So the asterisk or the star sign is used to create a pointer variable. Note that the type of the pointer has to match the type of the variable you are working with. So use the AND operator to store the memory address of the variable called food, right? So we'll use the AND operator to get the memory address of our variable and then assign it to the pointer. Now pointer holds the value of food's memory address, or in our case, it's holding the memory address of x variable. And over here you can give the star with int, or you can say star pointer. You could give it like this, right? Or you could have given it in between. Everything is the same, right? So whichever declaration is easier, that you can use. Like you can say int star pointer, or you can say you can give the star after int, or you could have given it in between, right? So whatever is convenient to you, that way you can create your pointer.
Okay.
All right. And one more thing, you can see this memory address is continuously changing. Right now it's 84C in the end. If I just run this again, it's 85C. So every time when we run the program, it's not compulsory that a variable is saved in the same memory location that it was saved in before. It is always or mostly saved in a different memory address or location every time you run the program.
Okay.
All right. So, like, here's the exercise. Did you do the exercise of the references chapter?
Sorry.
Did you do the exercises of the references chapter?
Yeah, I've done it.
All right. Now we are on dereferencing, right? So, we can, till now we are getting the memory address and saving it. What if someone gives us a memory address and we want to get the value out of that memory address? So, whatever value is saved in that memory address, we want to bring it. If we have just the memory address, then we can use dereferencing, right? So in the example from the previous page, we use the pointer variable to get the memory address of a variable. So we were saving the memory address of the variable using by creating a pointer variable and bringing the memory address using the AND keyword. So, however, you can also use the pointer to get the value of the variable. You can also use the pointer to get a value of the variable by using the star operator. So, the star operator is also used to create pointers. It is also used to dereference pointers. So, let's just remove this. As we know, index and pointer is the same. So, if we show pointer, to get the value that is there in that memory location, whenever we are using pointer, we just have to give a star before it, and then it will bring us the value that is there in that memory address. So as we know, in X memory address we have 10, right? So in whatever memory address X value saved, uh, uh, the value is 10 in that memory address, right? So X value is 10, so in the memory address we have 10. So we are seeing star pointer over here. So we are dereferencing the pointer variable, and it will bring us 10 from the memory location. Is this clear?
Okay. Yeah.
All right. Do you have any doubts?
No, it's clear.
All right. So note that the star sign can be confusing here, as it does two different things in our code. We used in declaration, that is string star pointer, it creates a pointer variable, right? When you not used in declaration, it acts as a dereference operator. So it does two things. Like the plus operator is used for concatenation and adding numbers. Similarly, the star operator is used to create a pointer variable and also used as a dereference operator. So now we can modify pointer values also, right? So we'll use this food example only to understand this. So you can also change the pointer's value, but note that will also change the value of the original variable. So let's see. All right. So we have food pizza, and then we are creating a pointer variable that will save the memory location of the food variable. All right.
Hmm.
Next we are gonna show the food's value. So we'll get pizza, obviously, right? Next, what we'll show the memory address of the food variable using AND a keyword. So that will give us the memory address. When we print the uh, pointer value, we'll get the same as the above value, that is AND food, because and food and pointer are the same thing, right? So we'll get to we'll show the pointer value, or let's just dereference it, so we'll get the food's value also, right? Now is the interesting part. What we do, if we say star pointer is equals to, for example, burger, so what this will do, this will, whatever is there in the memory location, that is pizza, in the pointers in the pointer variable we have the memory location of food, right? So in that memory location we have pizza. Whatever value is there in that memory location, we are changing it to burger. So we are changing pizza to burger, right? So now when we dereference our pointer, we'll get burger. And and when we print the value of food, then also we'll get burger. So using the pointer variable, you can also change the value of your variable. So using pointers, you can change the value of your variable also, right? So let's just run this program. So we have first the value of food, that is pizza. Then we have the memory location of food, that is this. Then we are dereferencing the memory location. So we have pizza. Then we are saying we are just doing star pointer equals to burger. So whatever value is there in the pointers in the food's memory location, there we are changing that value to burger. So now when we dereference the pointer, we'll get burger, and when we show the value of food, we'll get burger, as we are changing the value of our food variable using the pointer variable. So is this clear, or any doubts?
Now it's clear.
All right. So using pointers you can get your so using the memory location, you can save your memory location using pointers. You can dereference the memory location using pointers, and you can change the value of your variable using pointers. So there are three uses that we have seen of pointers right now. All right, so now we are on our functions, right? So this is a new concept for us. Till now we have been this is not that new, as we are already creating this main function, right? We are already using this main function, and we do have an idea of our main function, but this is a mandatory function. We can also create functions for our own use in the program to reuse code, and um, for our easiness, right? All right. So a function is a block of code which only runs when it is called. So it is only runs when it is called. Now you may be wondering, why is main running if it is not called? Because main is a mandatory function, and whenever you run the C++ code, it looks for the main function to automatically execute it. When we create our own functions, we'll have to run them ourselves. So we'll have to call them ourselves. They won't run by themselves. So if I create a function x, I'll have to call the function x. It won't run by itself. So you can pass data known as parameters into a function. So you can pass data. We are gonna see all of this. So have you done functions in Python? It will be much easier.
Yeah, the def functions.
Yeah. So it will be very easy to understand now. So functions are used to perform certain actions, and they are important for reusing code. They define the code once and use it many times. So if you want to reuse some code, then you just have to define the code once, and you can reuse it as many times as you want using functions. So
Okay.
now we are gonna see how to create a function. So C++ provides some predefined functions such as main, which is used to execute code. But you can also create your own functions to perform certain actions. So to create, often referred as to declare. So to declare a function, specify the name of the function. All right. So what we'll say,
Yeah.
we'll say void and for example x, and then we have to give parentheses, and then we'll give braces. So this is our declaration of the function, right? So this is how you can define a function, right? So my function is the name of the function. Now void, what is void? Void basically tells that this method won't return anything. We have main that will return an integer value, but we are not returning anything, because if we don't return anything in the main function, it will automatically return 0, right? So it will automatically return 0. We don't have to give return 0 in the end. The main function can automatically return 0. Over here we are giving void x, meaning this won't return us a value. Now returning a value means that you can use x method as a value, So whenever you return like 0 from this method, if I say void x, instead of void x I'll say int, meaning that this will return an integer value. So now returning means I can use this x function as a value. So I can say int y is equals to x. So I can call x and that will give us a value that is stored in y, right? So we are able to use x as a value over here. Whereas when you don't return anything, when we have void, for example, and like for example we are only, what we are doing, we are just printing hi, right? Now we cannot use it as a value. If I try to do like a string y is equals to x, so it does not know what to give y, what value should it give to y, right? It does not know what value should it give to y. So you'll have to call the function like this, right? So you'll call the function like this x, and whatever is there will be executed in it when it is not returning a value. So
Okay.
void basically means that we are not returning a value. So void means that the function does not have a return value. You will learn more about return values later in the next chapter. Alright. So inside the function, the code that add the code that defines what the function should do. So inside this x function, we'll add the code to define what this function will do. Now call a function. So declared functions are not executed immediately. They are saved for later use. Instead of the main function that is automatically called, all the other functions that you create won't execute automatically. They will be saved for later use and will be executed later when they are called. So this is how you can call the function. You give the name of the function followed by parenthesis and then add a semicolon. So in the following example,
Okay.
my function is used to print a text. So for example, over here in the following example, my function is used to print a text. Like we have the x function that is used to print hi. Similarly, in this, my function is used to print a text, right? And when it is called, so the text will be printed when it is called. So when we are calling x, the text will be printed. So hi should be printed before pizza. So you get hi first, and because we are not adding a new line, we are getting pizza in the same line. So should I delete this code of pointers?
Yeah, sure.
Alright. So a function can be called multiple times. You can call the function as many times as you want. So like I can call it 5 times, 10 times, 100 times. It does not matter, right? So function declaration and definition. So there are two things, declaration and definition. So in C++ functions, a C++ function consists of two parts. So one is the declaration, right, where you will give the return type, or if there is a return type at all. So over here we are giving void, meaning this function won't return anything. Then you will give the name of the function in the declaration. Then you will give the parenthesis, and then you will give the parameters if there are any. In the body you will give the code that needs to be executed. So there are two parts of the function, declaration and definition. Is this clear?
Yeah, it's clear.
Alright. So if a user defined function such as my function is declared after the main function, an error will occur. So if we say, if I give void x after defining the main function, it will lead to an error because it will try to execute the main function and it won't find the definition of our x function. Oh, right? So it won't be able to find the x function. That's why it's giving us an error when calling the x function inside the main function. So we are defining it afterwards, after the main function. So is it clear why it is bringing an error?
That's great.
Alright. So however, it is possible to separate the declaration and the definition of the function for code optimization. Right? So you can basically separate the declaration and the definition of the function. So we'll see how. You will often see C++ programs that have a function declared above main and function definition below main. This will make the code better organized and easier to read. So what we have over here in this example, we have the declaration on the top, then we are defining the main function, then we are giving the definition of the function, right? So we are giving the body to the function. So now what will happen, there's a concept named hoisting. This is called hoisting. So when the declaration is done and you give the definition afterwards, it is able to pick up the definition and able to execute the function, right? So when declared above and given the definition like after main, then because of the concept of hoisting, main function will be able to identify what to execute. So what will essentially happen, the declaration will happen first, then the definition will be given to it, and then the main function will be uh, so whenever giving the declaration on the top, the program knows that this method will have a body and it will seek for the body of the method, right, or the definition of the function. So finds the definition of the function first, it gives the definition of the function, and then it will call the main method.
Okay.
So when declared, the program knows that this function exists and it will try to find the definition of the function. So we'll just copy this example and paste
So
it.
like after declaring, we can add the code later on.
Yeah, yeah. And because of the concept of hoisting.
Okay.
So it's basically a term, hoisting, that will the program will know that the declaration is there. So there must be a body of the function also. So it will first look for the body. It will give the definition of the function, and then it will call the function afterwards.
Okay.
Now we are on parameters, right? So parameters and arguments. I'll just have a sip of water first. All right. So parameters and arguments. So there are two different terms, parameters and arguments. So parameters are those where like which you give in the function to accept, like parameter 1, parameter 2, parameter 3. And arguments are those when calling the function, when you give the, like for example over here I say int x, right? So that's a parameter of this function. But when I'm giving the value to x like 0, that's an argument. So 0 is an argument. So 0 is an argument, and int x is or sorry, in the declaration I also have to give int x, right? So 0 is an argument, and when accepting the argument, this is a parameter, x is a parameter and 0 is the argument over here. So argument and parameters are interchange, it can be interchanged and be used anytime. So you can call this an parameter and argument, or you can call this a parameter or argument, right? It depends and on your preference, but mostly this is called a parameter, x is called a parameter mostly, and the value that is passed to the my function is called argument. Is this clear?
Yeah, it's clear.
Alright, so information can be passed to functions as a parameter. Parameters act as a variable inside the function. So they act as a variable inside the function. So parameters are specified after the function name inside the parenthesis. You can add as many parameters as you want, just separate them with a comma. So we can give multiple parameters, but we just have to separate them with a comma. So the following example has a function that takes a string called fname as a parameter, right? When the function is called, we pass along the first name, which is used inside the function to print the full name. So over here, we'll just copy this code and then understand it. And we don't need to give returns here. Alright, so over here we have my function in which it is taking fname, and after every first name, right, it will add the last name refs. Okay, so this is a complicated last name. Let's just add Gupta or something. So whatever the first name will be passed, it will add Gupta after it, or let's just say let's just make this a greeting function. We'll say whatever this first name is passed, we'll give hi before it, hi before it, and then we'll add a new line also. Alright, so this if I pass Liam, it will say hi Liam. If I press pass Jenny, it will say hi Jenny. If I say uh, Anja, it will give hi Anja. So this is a greeting function. Instead of again and again writing the statement see out hi person, we can directly create a function that will take in the first name and it greet the person. So it's taking in the first name, the my function, and it will greet that person. So
Okay.
so the information that is passed is a parameter, right? So the parameter is the information of the function, data for the function. So when a parameter is passed to the function, it is called an argument. So as I told you, this is an argument. This is the value that is being passed, and this is the parameter. So the variables in the function are the parameter, and the values that are being passed are the arguments. So for from the example above, f name is a parameter, while Liam, Jenny, and Anja are arguments. So next we have default parameter values. So when we are uncertain that if when we are uncertain if we will receive the parameter value, right? If an argument will be passed, if we are uncertain about that, we can give a default value like uh, what can we say? John, right? So what we have over here, this is the default parameter. So when we are saying my function Liam, f name is passed and it will greet Liam. When saying Jenny, it will f name is passed and it will greet Jenny. But now we are giving nothing, right? So when giving nothing, it will check. Oh, it's not received an argument. So what it will do, it will set the value of f name automatically to John, right? So this is the default value. It will check if a value is being passed, then set the value of f name to the argument value, that is like in this example Liam, in this example Jenny. But when no value is passed like over here, then it will set the value of f name to John, right? So it will this is the default value that will check if no value is passed, then set the parameter value to the default value. So we get hi Liam, hi Jenny, and in the end we are not passing anything, so we are getting hi John.
Okay.
So you can also let's just read this. So you can also use a default parameter value by using the equal sign. So if we call the function without an argument, it uses the default value Norway. So we have my function country, that is taking in country and printing the country name. So when we call function, we pass it Sweden first, so it will show Sweden, then India, then we are not passing anything. So it will take the default value that we give over here, that is Norway, and print Norway, and then it will show USA. So a parameter
Okay.
with a default value is often known as an optional parameter. So this parameter has a special name, optional parameter. When you give a default value to a parameter, it's known as optional parameter. So from the example above, country is an optional parameter and Norway is the default value. Country is an optional parameter and Norway is the default value of that parameter. Now here's an example of basically accepting multiple parameters and using them. So inside the function you can add as many parameters as you want, right? So we know that. So it's taking in f name and age, and it is gonna show the name, and then it will add the surname and it will tell the age of that person. So if we pass Liam 3, it will show Liam 3 years old, Jenny 14 years old, Anja 30 years old, and so on. So we can have multiple parameters also that we already know. So note that when you are working with multiple parameters, the function call must have, right? The function call must have the same number of arguments as there are parameters, right? So the function call must have the same number of uh, arguments as there are parameters. So if you are, let's just make this example more clear. Let's just say uh, integer x, integer x, and integer y. Now you can't do like, if you want, when calling, let's just call my function. Now because it is accepting two what we say, parameters, you'll have to give it two arguments like 0 and 0, right? So you'll have to give it two arguments if it is accepting two parameters, right? You can't say that you are giving three arguments or one argument, right? If it is accepting two parameters, you'll have to give two arguments too, right? So the function call must have the same number of arguments as there are parameters, and the arguments must be passed in the same order, right? So if you want to set the value of y to 0 and x to 1, you can't say 0 comma 1. That will set the value of x to 0 and y to 1. You will have to give it in the same order. So if you want to set x value to 1, you will have to say 1. If you want to set y value to 0, you'll have to say 0. In the same order as the parameters, you'll have to give the arguments. So is this clear?
Okay. Yeah.
So now we are gonna see about learn about return values. We already know a bit, but let's just see. The void keyword used in the previous example indicates that the function should not return a value. If you want the function to return a value, you can use a data type such as int, string instead of void, right? So we can instead of void, we can give a data type over here like int, right? And this will tell that this function will return an integer value. If I say string, this will tell that this function will return a string value. If I say bool, it will tell that this function will return a boolean value, right? And so on, instead of void. And use the return keyword inside the function. But when giving this, you'll always have to use the return keyword. So let's just make this return an integer, and we'll say this is the add function, right? So this is the add function that will add two numbers, right? We will call the add function, we'll pass it two values, right? And we'll return x plus y, right? Now what is happening, we are passing 1 and 0 to it. It will add the two values and it will return it, but the return value, we are not doing with anything with the return value, right? We just have it over here present. So what we can do, we can say integer sum is equals to this, right? And then we can show sum, right? So this will show the sum, right? So return, as I told you, will treat the function as a value, right? So this will give us 1. If I say, let's just see, yeah, if I say 200 plus 39, then it will give us 239, right? So this will give us the sum.
Okay.
And even better, if we don't want an extra variable in our program, we can just directly show the value. As add 239 is giving us a value, then we can directly show it from cout. So add 200 plus 39, and this will give us this will return us the value, the sum value, and then we are directly showing it using cout. So this will give us the same result. So is this clear?
Yeah, it's clear.
Alright, so you must have done the return keyword in Python, right?
Yeah.
Yeah. So this must be easy. So here they are creating they're creating a function which is taking it and parameter and adding 5 to it and then returning the value that is directly printed. The example returns the sum of a function with two parameters. So this is the same function that we created over here, that is returning the sum, right, of two values. So you can also store the result in a variable. So we also stored the result in the variable, in the sum variable. They are also storing the result in the sum variable, right, and then showing the value. Alright, so we have already done this. Now this is an interesting concept that is not there in Python and a new concept for us, and it's very important. Pass by reference. So in the examples from the previous page, we used normal variables when we pass parameters to a function, right? So we were accepting like normal variables, int x, int y, right? There's nothing special in these variables. We can also pass a reference to the function. So like we had reference variables, right? So in the we had reference variables that were pointing to the same memory location. So like we had food and meal which were pointing to the same memory location. Let's just go back over here. So we have food and meal that have the same value and are pointing to the same memory location. Similarly, you can pass by reference parameters, right? So whenever, like for example, passing a variable to swap nums over here in swap nums x, and that variable will point to the same memory location. So we'll see that in detail right now. This can be useful when you need to change the value of the arguments. All right, so over here we have a case where we want to swap the two numbers. So we have first num and we have second num, right? And we want to swap both of its values, right? So either we can do this directly over here, or we can create a method for it to swap the numbers, right? But when creating a method, you can swap as many variables as you want. But if you do it right over here, you'll have to rewrite the code again and again. So creating a method is much better, right? And more practical, right? So let's just copy this code and let's understand what is happening. We'll not look at swap nums, right? First we are gonna see we have first num and second num, right? We are before showing before swap first num, second num, right? So we are seeing before swap, first it's showing a first num value and second num value. Now we are passing to swap nums a first num and second num. So what is happening, x is a reference to first num and second num, and y is a reference to second num. That means that when x value will be changed, then first num value will also be changed. When y value will be changed, then second num value will also get changed, right? So now to swap, we just have to swap the values of x and y inside the swap nums, and it will automatically change the value of first num and second num, as the x and y are references to first num and second num. So you have int z is equals to x, x is equals to y, y equals to z. So we are saying int z is equals to x, so we are storing the value of x in the z variable. We are changing the value of x to y. So that is, we are changing the value of 10 to 20, right? So now x is 20 and first num is also 20, and we are saying y is equals to z. So because z had 10, y is equals to z. So now second num is 10. So now both the values have been swapped. So we will have 20 and 10. So we'll have first num 20 and second num 10, as we had references that we were accepting over here. Is this clear, or
Okay.
do you have any doubt? I'll just re-explain it.
No, it's clear. I was just reading it.
Alright. So it's clear now that we are accepting references, and those references are changing the outer values also of first num and second
Yeah,
num.
yeah, it's clear.
Alright. Very good. Now we are on the pass arrays chapter. So very small chapter. So we'll try to complete it right now. So we can also pass arrays as function parameters. So you can also pass arrays to a function. So you have my function that is accepting an arrays. It will accept an integer array with 5 elements only, and this function will basically loop on the array and show each element that we saw in the looping chapter, right? In the arrays chapter also, right? So next we have the main function, in which we are creating an array with 5 elements, right? And we are passing the function my numbers that will basically loop on the array and show each value, right? This function is basically looping on the array and displaying each value, right? Nothing like new. So the function my function takes an array as its parameter and loops through the array elements with the for loop. When the function is called inside the main, we pass along the my numbers array. So we are giving the function the array, right, which outputs the array elements, right? So Note that when you call the function, you only need to use the name of the array when passing it as an argument, right? However, the full declaration of the array is needed in the function parameter in my numbers 5, right? So over here you have to give my numbers only as you are passing this array, right? You don't have to give like my numbers and then you don't have to give 5 after it, right? It's directly, you just have to give the value my numbers and it will automatically accept it. It will know that it has 5 parameters and it's an integer array. If you try to pass it as string array, or if you try to pass it an array with more elements than 5 elements, then it won't work, right? So this was it for today's class. I hope you liked it, and I'll see you tomorrow in the next one.